A 30, 60, 90 triangle is a right triangle where the three interior angles measure 30 degrees, 60 degrees, and 90 degrees. Right triangles with 30, 60, 90 interior angles are known as special right triangles because of the powerful relationships that unfold when studying their angles and sides. In all triangles, the relationships between angles and their opposite sides are easy to understand. The greater the angle, the longer the opposite side. The largest interior angle is opposite the longest of the three sides, and the smallest angle will be opposite the shortest side. In a right triangle, recall that the side opposite the right angle is called the hypotenuse, and the other two sides are called legs. The sides of a 30, 60, 90 degree triangle have a special ratio, 1/2 by the square root of 3. The short leg equals x, the hypotenuse equals 2x, and the long leg equals x times the square root of 3. These three special properties can be considered the 30, 60, 90 triangle theorem. 1. The hypotenuse is always twice the length of the short leg. 2. The length of the longer leg is the short leg's length times the square root of 3. 3. If you know the length of any one side of a 30, 60, 90 triangle, you can find the missing side lengths. Other interesting properties of 30, 60, 90 triangles are: all 30, 60, 90 triangles are similar, and two 30, 60, 90 triangles sharing a long leg form an equilateral triangle. Here we have a 30, 60, 90 triangle. We know that the hypotenuse of this triangle is twice the length of the short leg, so we can find the short leg, or x, by solving 3.46 kilometers divided by 2, which equals 1.73 kilometers. We also know that the long leg is the short leg multiplied times the square root of 3, so we have 1.73 times the square root of 3 equals approximately 3 kilometers. Here is another example. The long leg is the short leg times the square root of 3. So can you calculate the short leg's length? Did you say 5? That's correct. The length of the hypotenuse is always twice the short leg's length, so the hypotenuse equals 10. This table of 30, 60, 90 triangle rules helps you find the missing side lengths. What if the long leg is labeled with a simple whole number? You leap into the problem since getting the short leg is simply a matter of dividing the long leg by the square root of 3, then doubling that to get the hypotenuse. But you cannot leave the problem like this. The rules of mathematics do not permit a radical in the denominator, so you must rationalize the fraction. Multiply both numerator and denominator times the square root of 3. This simplifies to. Unless your directions are to provide a decimal answer, this can be your final answer for the length of the short side. Doubling this gives 18 times the square root of 3 for the hypotenuse. Remember, a 30, 60, 90 triangle is still a triangle, so its interior angles must add to 180 degrees, and its three sides must still adhere to the Pythagorean theorem. A squared plus b squared equals c squared. You can use the Pythagorean theorem to check your work or to jumpstart a solution. Let's look at an example of a right triangle that has a short side with a length of 14 meters, with the opposite angle measuring 30 degrees. What are the other two lengths? We know immediately that the triangle is a 30, 60, 90. Since the two identified angles sum to 120 degrees. 180 degrees minus 120 degrees equals 60 degrees. The missing angle measures 60 degrees. It follows that the hypotenuse is 28 meters and the long leg is 14 meters times the square root of 3.